Yeah, I hope my screen is visible. I already shared it.
One second, sir. So we can see your screen, sir.
Okay.
Good morning, everyone. I wish everyone is doing well. So, today's webinar is going to be extremely interesting for all of us. I hope by the end of the webinar, we all will be having a lot of questions. So, for now, we'll keep it on hold. And without further ado, I now welcome Dr. Nagarajan, Head GIS and Remote Sensing, MSSRF Chennai. He is a renowned scientist in this field. So, he has contributed a lot of pioneer things to the science industry. So, welcome, sir, and thank you for being with us. So, before we proceed with your permission, sir, I would like to give a short introduction about the today's webinar to our audience.
Yes.
Yes, sir. Thank you, sir. So, on behalf of MS Swaminathan Research Foundation, Coastal Resources and Fisheries Program, I warmly welcome you all to the 31st session of the MS 100 webinar series. So, this webinar series is being organized as part of the centenary celebrations of MS Swaminathan to commemorate and reflect upon his visionary contributions to fisheries, coastal resource management, sustainability, and community-centered development. The topic of today's webinar is GeoAI for data-driven coastal resource management in the blue economy. We are privileged to have with us Dr. Nagarajan, Head GIS and Remote Sensing MSRF Chennai. So, Dr. Nagarajan is a geospatial technology leader with over 20 years of experience in GIS, remote sensing, and AI ML for Earth observation, focusing on agriculture, blue carbon, and climate resilience. He has extensive expertise in transforming spatial data into actionable intelligence, managing large-scale geospatial systems, and scaling satellite-driven platforms for sustainable development. He pioneered Penai, a mobile-based agri-tech application, and the Geo Agri Portal, India's first platform delivering cadastral-level satellite advisories directly to farmers using multi-sensor data, weather analytics, and machine learning models. So he currently leads a Microsoft-funded project on quantification of blue carbon for Tamil Nadu using drone imaging and GeoAI. India's first initiative applying drone-based multispectral image and AI analytics for carbon accounting in seagrass and mangrove ecosystem. He holds a PhD in mangrove carbon stock assessment using machine learning techniques for RED Plus as MSc in spatial information technology and a BSc in physics. He has worked with organizations such as World Bank, CIZ, and Google, and its research spans blue carbon ecosystem, climate risk, water resource planning, and carbon biodiversity, with significant contributions across MSRF program areas. So today's talk will mostly highlight about an overview of GeoAI for data-driven coastal resource management in the blue economy, highlighting how the integration of geospatial technologies with artificial intelligence can address key challenges in coastal and marine systems. It will explore practical applications of GeoAI in habitat monitoring, shoreline change analysis, disaster risk reduction, fisheries management, and blue carbon ecosystem mapping and carbon stock estimation. The seminar will emphasize how data-driven decision support systems support conservation, climate mitigation, and resilient livelihoods. While enabling effective governance, it will also discuss future directions for leveraging GeoAI to strengthen sustainable coastal development and advance in inclusive climate resilient blue economy. I kindly request everyone to join us for this insightful session, which will shed light on the critical role of AI in remote sensing for managing coastal resource focusing mostly in the blue economy, which is currently a blooming sector. So now now with due respect, I request Dr. Nagarajan to take over and continue the session. Thank you, sir.
Yeah, thank you, Dr. Swapna, for giving a brief, long introduction about me. Good morning, all. Uh, Today, I'm going to share the insights about the GAA, how GAA can be used for our coastal resource management in the context of blue economy. I hope I'm loud and clear.
Yes, sir.
Yeah, thank you. So, as you all aware, coastal regions are the most dynamic and valuable ecosystems on our planet. But this is the highly vulnerable is our coastal ecosystem only because most of the business is happening here, and which is millions and billions of populations are living along the coast of globally actually, and it's also rich in biodiversity, and it protects the shorelines actually. So this ecosystem, this coastal asset actually has to be, properly managed, and it has to be protected as well actually. So for managing these coastal resources requires a decision actually that are not only timely, and it should be informed, reliable, and spatially explicit data actually. So that's a key objective of this presentation as well actually. So where GeoAI will be a powerful enabler actually. So GeoAI means like geospatial artificial intelligence. So by integrating the GeoAI intelligence with the satellite observations, drones, and field measurements, and machine learning algorithms and deep learning algorithms. So these put together is called geospatial artificial intelligence. And before the maps, what are we are used is one is static map actually. So now after this Geo AI process actually, so this map should be dynamic and it should be a data driven actually. So which whatever the policymakers or the decision makers and the practitioners actually, they have to use a GeoAI for a decision support system, as well as it enables them for their any projects and intervention actually. So in this talk actually, so I'll be highlighting more about how mangroves and seagrasses ecosystems actually mapped can be evaluated, and shoreline changes and fisheries and climate risk management and so on. So tools actually that how we can bridge the science policy and the practice. That's a key one. And ultimately, the goal is not just for maps, actually, it is for a better decision. How this can be used for better decision, and for long term sustainability actually. So I'll just go to the, so if any doubts actually, can people can stop me actually, so we can just clarify it now and then as well. Okay. So what is blue economy? So as I said the earlier actually, so blue economy means actually, so whatever we are seeing in the coastal actually, it's called blue economy actually. So blue economy specifically means that your fisheries and aquaculture, tourism and shipping and allied sectors, and providing incomes and employment for the millions of people around here actually. And the resources, the coastal resources which we are talking here is mostly on mangrove seagrass, coral reefs, which regulates the climate as well as store more carbon and protect shorelines, and which supports the biodiversity. So since most of us are in the coastal system, actually, we are very much aware of the coastal resources applications, as well as the value of the coastal ecosystems in our even in our Indian coast as well, actually. Yeah, and also how it affects the climate change, and how the sea level rises and population growth and the unsustainable resource extractions intensify the stress on the coastal and marine environment. So these are the stress for the coastal, and which we can't avoid it, but we have to manage it actually. So how we can manage it? So how the data can be used actually to manage these coastal resources, to further how we can address the stress issues, how we can quantify some of the resources, how we can quantify the carbon potentials, carbon storage, and all these things has to be studied actually. And yeah, this is some of the coastal challenges. As I said earlier, you all aware like, what are the coastal challenges we have actually. Most of the coastal resource challenges are with the cyclones and extreme events and storm surges and sea level rises. These are the most complicated stresses for us actually. Even to certain extent, we have coastal pollution, and coastal pollutions in different way actually, through from inland as well as from the coast itself actually we have pollutions as well. So how we can do this, and monitoring this is not an easy task actually. So as you know, this is around like 7,000 square kilometer of coast in India, and 1,000 square kilometer of coast in Tamil Nadu actually. So it's not so easy to monitor it actually through now conventional methods actually. So So monitoring difficulties also there actually. So where we need advanced tools to monitor this, and keeping this advantages of advances in drone and your our satellites and other thing. So technologies are improving to manage and measure and monitor our coastal ecosystems and stresses also. Based on that, the climate resilience measures has to be taken actually. And coming to what is GeoAI, GeoAI, as I said, it is a geospatial artificial intelligence. So, which is a combination of a geographical information system, remote sensing, and artificial intelligence and machine learning techniques. So, just to give a brief introduction about GIS, actually, so GIS is a information system which is reference to the geography. Actually, that's basic about the geographical information system. This has been we have been using GIS and remote sensing for more than for 50 to 60 years. Actually, we have been using GIS and remote sensing. Before that, we have only maps. Actually, as you've seen, some of the topographic maps, some of our cadastral maps, and so on. So maps are there, but which is very static map. It is not a processed or dynamic map. Actually. So that's how GIS come into the picture, and GIS is everywhere now. Actually, so most of you would have seen it, would have used also actually, where if you're going from one place to another place, we use Google Maps. And if you want to track your packages, if you want to track your driving and so on, so we are using GIS. So indirectly, everybody is using GIS in their daily lifetime. And coming to remote sensing is it's very booming now actually. So remote sensing is nothing but sensing an distance object without any touch actually. That's called remote sensing. So ideally, remote sensing, what we are speaking here is a satellite-based remote sensing, and now it's drone-based also. So we launched so many satellites actually, and many people, every week at least, we know that from Sriharikota we are keep launching satellites actually from the rocket. So that is for the purpose of monitoring and management of the resources actually. So remote sensing is that actually. So how the remote sensing is going to support the GIS and going to support uh, our management of all the natural resource management, and as well as some other application as well. And finally, artificial intelligence, this is a term like every day, every hour we are hearing actually, or every from schools to colleges to government agencies to corporates, everybody is talking about artificial intelligence. So artificial intelligence is nothing but how the process can be automated, how the process can be made automated actually. So this is a step actually we did this in long term, but now there is a lot of algorithm development and cloud-based algorithms. All these things come up actually, which makes the life very easy, and which is helping us to detect the problems quickly and analysis quickly, and store the data as well. We are generating huge amount of data. So earlier, if you take like 10 years or 15 years back, when we process one single satellite image, it takes a lot of time for us actually. Even data corrections and all these rectification too, it will take more time actually. Now everything in the cloud actually, you just capture the image, you process it. Even algorithms also in the cloud actually, you can process it, process the different algorithms to get this sense. So that is about the artificial intelligence. And different artificial intelligence is nothing but different algorithms. It's called machine learning algorithms, deep learning algorithms. All these algorithms has been processed actually. So if anybody is interested in this, we can talk more about this in after the session as well actually. Okay, so coming to the data source actually, so data source is different data source for this. One is a cloud-based platforms, which I said earlier. So a lot of data are in the cloud nowadays. Actually, you don't need to rely on most of the data are open source as well. So anybody can take the satellite images or some of the shared data, secondary data can be taken and do the analysis in the software itself. And of course, satellite imagery, as I said, satellite imagery is one of the main source for the coastal studies actually. So so coastal studies are very long actually, so which needs to be studied using satellite imagery only to have a broader understanding of this one. And of course, drone data. And drone, as you all know, that this is also for last few years the booming actually. So drone will have a very deeper understanding of that study area actually. Say for example, if I want to take a studies for the entire Tamil Nadu coast actually, so I will go for a satellite imagery, quickly do the analysis and other things. If I want to concentrate more on some particular study area like Rameshwaram or Nagpatnam actually, so where particular these things we can use the drone images. Drone based images also can be collected and processed and for analysis ones. So this will give you a quick understanding and the near real-time analysis also possible. So nowadays, earlier, we used to have only very low temporal resolution images actually, so where we'd be getting images like 30 days or 1 month. Now we are getting 15 days images actually. Every 15 days we keep on getting images and using this drone actually. So even quickly within a day also you can do the process actually. So that's a advantage of our drone and also field essay. And these are some of the oceanographic data and climate data sets actually from the IMD and different sources and socioeconomic data sets to understand the human impact and the coastal resources. Yeah, many organizations are collecting the data. So these are the key data required for any coastal studies actually for any projects. And yeah, some of the example actually. So this is about how we measure in our program area actually. We have been using remote sensing for more than 3 decades for the coastal system research actually. So where for all the mangrove planning and monitoring and restoration programs actually, so we extensively use this satellite images actually. So how we can measure the changes over the time, how we can plan and how we can protect other things. So on your screen, what you're seeing is a Landsat image. And Landsat is one particular satellite image which has a repository of the old images from 70s onwards actually. And the beauty of remote sensing is, we are lucky to process and understand the past images as well. So if I want to see like 40 years before how it was there, I have a repository of the satellite image actually where I can pull it, I can do the analysis, and based on that I can see this is a past image and how it looks like that, how it looks now actually. So what you're seeing on screen is a 90 satellite image. This is a Godavari mangrove region of Andhra Pradesh scheme, and whatever the bright red actually looks bright red is the mangrove region. So mangroves are one of the important coastal resources actually. So where we have been working in this mangrove restoration efforts for more than 3 decades actually. So you can see based on our restoration efforts how it has been changed. So these are some of this. I hope you can see the my arrow mark actually. So where some of the high points actually, so how has been restored over the period of time. So what is the beauty of this thing is, without remote sensing, it is very difficult to quantify the changes in the area as well as how much has been restored actually. So this has been converted into GIS actually, where the raw satellite image has been processed using some different classification techniques, and based on that we classified how much mangroves and mudflats and sand and other vegetations in that particular reserve forest area. You can see these green patches are the mangroves and the light grays, mudflats and sands and other vegetations. So this will be very useful for the practitioners, like how they can increase the mangrove ecosystem, mangrove restoration efforts, and where they can do the mangrove restoration, and how they can manage other services as well, like mudflats and sands and so on. So you can see these are the patches in the middle. These areas where we did the restoration, and based on our restoration effort actually this much area has been converted actually. So you can see in the area in the mangroves, like earlier it was 16,000 hectares in 1990, and after the restoration it will become 18,000 hectares. This is with the different agencies and the government also involved in this restoration. And finally, we can see the change reduction, how the changes has been happened. So the newly found mangroves is around 2,000 hectares, 2,700 hectares actually. So you can see the dark green patches. These are the areas restored mangroves area actually. So, and we still have the degraded mangrove areas also. So degraded mangrove areas is around 1,200 hectares of degraded mangroves are identified by this analysis. So when we are mapping, we are not mapping only the existing features, actually existing resources. We are just mapping as well what are the potential to do that and where the areas are there actually. So in this map, it clearly shows there is 1,200 hectares of degraded mangroves are there, which means we have a scope to restore another 1,200 hectares of mangroves. So by having this in the hand, I mean, the marine biologist or the coast, I mean, foresters can go and do the restorations in this particular degraded mangrove area. So these are simply, we can use remote sensing for restoration and monitoring of the mangroves actually. So likewise, one of the major applications is also shoreline changes. So how the shoreline changes? You all know that we all hear from the everyday daily news actually because of the climate change and sea level rises and storm surges. Our shoreline also drastically changes actually. Somewhere there is an erosion is happening. Some area there is an accretion is happening. So how to monitor that? It's very difficult to monitor the erosion accretion. Simply, we know that this place is happening and here is happening, but if you see the length, actually, it's very difficult actually. So only through remote sensing and your other maps, actually, this is easily we can identify this area and we can see where this erosion recreation is happening. So on your left image, this is an digitized from the satellite images as well as some of the maps as well. And you can see how this area has been changed. The different lines are there from 1990 is a green line and one is 2000 is orange line. These are the shorelines. That's we digitize the shorelines and we can see how the shoreline is drastically changes here and there actually. Because of different natural phenomena. So we don't want to go into that phenomena. So we'll see the technique like how we can only measure and monitor this one. So until 2023, how you can see this? If you just see the image on the right, you can see how much area accretion and erosion is happened for every 10 years. This is for 10 years we did actually. So you can see there is an erosion of around minus 31. These colors are all eroded area. You can see your orange and red are eroded area and all this green are accretion area actually. So this is very useful for the planners and the policymakers to avoid the erosion as well. No, accretion is not a problem actually, so we are getting more land and everything, but erosion has to be stopped. See if you see this image, so most of the erosion is happening in the right near the coast where there are a lot of mangroves are there actually. So because of the mangroves only, the extent of erosion is also controlled actually. If imagine if there is no mangroves and this erosion would have been almost completely in the inland actually. So that's the most advantage of mangrove restoration as well. And having this map, actually the practitioners actually can make a policy like how we can control this erosion actually. So it clearly shows that this area is highly eroded and they have to have a policy for this and they have to have some solution to control this erosion in that shoreline. And next, coming to density. So this again in the mangrove area, how the density has been. So when we do a lot of restoration, actually, so we have to understand the density also. Where are the high density mangrove area there? Where is the less density mangroves are there? Where is open density mangroves are there? Also has to be mapped. And for this, we used a different technique we called NDVI, which is normal difference vegetation index. Based on this, we have published protocols actually based on the values. We define this as open, moderate, dense mangroves and dense mangroves. So wherever dense mangroves, we don't have any problem actually. The dense mangroves, that patches are very healthy, and that mangrove area has to be conserved actually. So that's the idea. You can see both the map, the dark green one is a dense mangroves. It's in the Krishna mangroves on your left, and on your right is uh, again Godavari mangroves. So the green patches, the dark green patches are the dense mangroves, where in the Krishna we have 6,000 hectares and and Godavari is almost 12,000 hectares. So we have open mangroves and we have moderate dense mangroves. So what is the purpose of this map is, for dense mangroves, as I said earlier, that area has to be conserved actually, where a lot of carbons also stored in that particular dense mangrove patches areas, and where there would be rich biodiversity area in that dense mangroves as well. And if you see the open mangroves, coming to the moderate and open mangroves, so the open mangroves is around 2,000 hectares in the Krishna and 2,000 hectares again in Godavari actually. So this area is a concentration. We have to concentrate on this area. How the open mangroves and moderate dense mangroves can be moved to the next level of dense mangroves. So for this will be very useful for the foresters actually, where they can concentrate on these areas as well for the restoration effort. So nowadays we are getting a lot of projects for the restoration of mangroves actually, but people are struggling to get land and they do not know where exactly to restore and where they can find the uh, land actually. So these maps will be helpful. As I shown in the earlier map, it is for degraded mangrove patches also can be restored, and now this open and moderate mangroves also can be restored. So that is the advantage of remote sensing and GIS actually, and quickly we can process it and we can give the map and we can give the different places actually where the restorations and conservation has to be taken care of. And yeah, next, this map is about species. So we have different species. So as you all aware, like we have different species of mangroves in the forest actually. So uh, by having the advantage of very high resolution satellite images, now we can differentiate the species as well. So in the image you can see for the Krishna mangroves, Avicenna rhizophora and Exocaria has been mapped. This is based on the spectral reflectance actually. So we've mapped, and this will also to just have a better understanding of a different mixture of species and how it performs in the forest as well. So you can see, and we have more Avicennia in Krishna mangroves, and if you see in the Godavari on your left, right, on your right, we have more exocaria species actually. So likewise, this will be helpful for the people actually, for scientific research and to understand how the different types of species are surviving in the mangrove environment, and how we can increase different species, because we can't promote mono species in any forest actually. It has to be diverse actually. So this will be helpful for any foresters or ecologists actually to understand the dense patches of different species and how they can improve the quality and health of the different species as well. And for this purpose, we use extensively different GeoA algorithms to classify the pixels in the same regions actually. So based on different minute difference in the spectral reflectance, the different species also has been classified here. Yeah, and this is one of the new project actually. So where we are working currently to map the seagrass extent. So seagrass is one of the important ecosystem actually, which is not even mapped properly in ecosystem in our India as well. And you all know that in India, some part of Gujarat and mostly in Tamil Nadu, Gulf of Mannar and Palm Bay, we are rich in seagrass meadows. It is high time to measure, to map the seagrass meadows in our Tamil Nadu forest area actually. So where this project is exclusively, we are going to map this seagrass area, and we will be using high resolution drone images as well. So this images from the satellite images. We are working with the different algorithms to test. This is just we started this project. We are using different algorithms and different machine learning methods and deep learning methods to quantify, to measure, to map the seagrass. So seagrass is one species actually which is underground, under the water actually. So we are expert in mapping whatever above the land actually. So we have very good algorithms. We are established protocols are there to measure it. But for to map the underground vegetation actually, so it is still the research actually globally as well actually. So we have started this one, and we got some pretty good results also, as you see on screen. And then this particular area we just tested with the different CNN network, CNN algorithms, and based on this you can see the results. If you see the coast, you can see the light green one, all seagrass actually. So we are the first in the country where we'll be flying drones for this actually. We are yet to fly the drones, and we are really excited like how the results going to become for this work actually. And as well the same processing actually, so we got the mangroves also. You can see the green patches where we have a dense mangroves, and we can see the view and the fishbone structure also you can see actually. These are the fishbone structures, and you can see the vegetation in the fishbone structure actually. So likewise, yeah, seagrass also we are mapping, and we are going to quantify the carbon also on the seagrass. And this is also one important ecosystem is salt marsh. So salt marsh is also one of the very important ecosystem, but this is completely neglected actually. So we don't have enough data or enough. There is no map at all for this salt marsh ecosystem, and we started working on that actually. So we have find there's so much of potential of salt marsh land is there actually, and to certain extent some of the salt marsh land are converted to mangroves also. And we're going to come up with a detailed map, and we'll be showing what are the potential salt marsh areas are there, how we can do some of the restoration of salt marsh land is not for any mangrove restoration, and to certain extent they're doing it, but upland area, at least they can go for some salt marsh based vegetation such as halifax and so on. So that also contributes more to the carbon potential actually. So we just started this work also recently. Yeah, this is about how we use satellite images and remote sensing for site selection actually. So any ecologist actually, if they want to go for mangrove restorations, they have to have find a place actually where they can do the restoration. And we, as a remote sensing people, actually use the satellite images, and based on satellite images, we'll highlight some of the area, potential restoration areas. You can see on the screen, actually, this is restoration area we identified. And we identified not only from the remote sensing images, and after that has to be again go for some of the data collection also. We have to collect the title data, soil maps, and digital elevation models as well, and to understand the topography of that area. And after the selection, actually, so once we selected that area, the people has to do some topography study as well to understand the topography of them, to have a proper fishbone structure, and to have the freshwater flow, and even the brackish water flow also. So it's likewise, once the area has been selected, and the whatever the selected area will be closely monitored. And you can see from the 20 years, the image what you're seeing on the left is 2023, and the image what you're seeing on the right is 2023. In the 20 years, you can see how much area has been covered with the mangroves now actually. So it is easy for any donors or any agencies actually to quickly validate our results, and to quickly appreciate our restoration efforts and this thing. Yeah, so this is again the same one. So where you can see the small patches in this close to this area, and how the restoration efforts has been taken over the period of time, and how it has been restored. And by monitoring these, actually, this is also very helpful for doing the mortality replacement also. So if you have if we can have a periodical monitoring through remote sensing, like every 3 months or every 6 months or 6 months duration, this area can be constantly monitored, and we can improve the quality and health of this ecosystems as well. Yeah. Again, for shelter belt actually, so this image clearly shows for shelter belt. So you all know that the importance of shelter belt actually for the heavy cyclones and storms. Such a shelter belt is also very important. Shelter belt is for the throughout the coast actually. So you can see this image before. So these areas has been identified as shelter belt, and you can see the after the restoration actually. So how the shelter belt become bioshield for this particular for this entire coast actually. So which clearly shows the effect of the restoration in this image as well. And coming to the disaster risk reduction, so you all know that as I said many times, actually, the cyclones and storm surges, floods, and sea level rise And these are some of the hazards for us actually. So extensively GIA and remote sensing is used for this. To understand the risk factors, to understand the vulnerability of the coast. So where there is this more sea level rises are there, where the more land has been eroded, how we can do it. And every district has a spatial planning, and I think every state has a coastal zone and land use planning report is there, and that's all prepared based on the GeoAI and remote sensing. And based on that, actually, a lot of researchers and climate resilience measures also happening actually. So yeah. And for cyclone also, for you all know that 2018 we have a Gaja cyclone that hit badly the Muthupet region actually. So you can see the from the image you can see the I mean how the area is completely affected actually. So most of the mangroves are uprooted in this region. Around 60% of mangroves has been lost in in this Muthupet region. Um you can see from this image actually what we're talking is this part on your extreme right left is a Muthupet mangrove actually, so where you can see these areas become gray actually. So these areas actually before cyclone, after cyclone, and you see on the right actually right one, this is completely washed off. So, which means that it absorbs most of the cyclone effect actually, and it saves the villages actually, which clearly shows that if there is no mangroves, most of the villages behind the mangroves would be washed off. So that is the advantage of mangroves, and that's the reason we are calling this as a bioshield actually. And you can see the impact of it. So having this map, having this satellite image, this is immediately after the cyclone we got this image, and we can see how much area we lost actually. And after this, and the government of Tamil Nadu is also putting a lot of effort. Even MSRF is also working extensively in this region for restoration of mangroves in the Muthupet region. And we are restoring the degraded area. And almost some of the areas has been restored, and some still work has been happening here. Yeah, this is a detailed map of this one. You can see on the top image, the green patch, dark green patches are some mangroves, and below after this image, and the mangrove, most of the mangroves are not there actually. Even in the entire coast also, if you see the dark green throughout the coast, you can see the dark coast. I mean patches. After cyclone, weather cyclone, it is completely lost actually. Yeah. And coming to this study we did exclusively, to understand the spatial temporal changes in the Peshawar mangroves actually. So Peshawar mangroves, you all know this is one of the rich mangrove ecosystem for Tamil Nadu, and where we have advantage of having a satellite image from 1977 actually. So we have taken the images from 1977. We mapped the mangroves there actually. If you see on the image from 1977, we have around 562 hectares of mangroves in the reserve forest. And every 10 years we mapped this, 5 years, yeah, 10 years 5 years we mapped it. And we can see 1988 images, there's drastic changes in the mangrove cover actually. It has come down to 300 hectares. So 1988, due to some anthropologic effects actually the mangroves are completely down actually. Again in 91 it's almost completely only 284 hectares of mangroves are there actually. So therein from 97 onwards it started increasing, wherein MSSRF and forest department actually joined, and they started doing the restoration work actually. You can see that from the 1977 there is a huge there is a drastic increase in the mangrove cover. You can see the image very clearly. You can see the image from 2001, 7, 12, 17, and 2022. Very recently, we have almost like 7, close to 700 hectares of mangroves in the uh, uh, reserve forest area itself actually. So you can see the single image in the screen, you can understand the spatial and temporal difference in the mangroves actually. So this is one of the evidence-based for our restoration effort, and even still people are doing some restoration in other part of reserve forest and non-reserve forest as well. Yeah, this is about the GIA in fisheries actually. So So fisheries, we are also pioneering in designating a potential fishing zone for the farmers, I mean the fishers in the east and west coast of India. And how it works actually, most of the data, what are the potential fishing zone data we're getting from inquiries are made through GeoAI actually. So where most of the data are the required data is from sea surface temperature and chlorophyll content and all this to put together, they have a potential fishing zone. So potential fishing zone applications also mostly widely used by for the satellites and the other things. And once the data has been disseminated to this and our through our FFM application, we are disseminating all the data to the fishers as well actually. We have there is a lot of other applications also there actually, so it's yet to be explored to how we can still use high resolution images, all these things in the courses as well. Yeah, and this is about the blue carbon project actually. So one is, so we have been restoring mangroves for more than 3 decades actually. So we know the extent of mangroves, how healthy the mangroves, how the dense mangroves are there. But we have to measure the carbon also. The aim of restoring mangroves is just not only increase the green cover actually. It is also for the ecosystem services, like how much carbon has been how much carbon has been stored and sink actually. So many studies shows that actually the mangrove stores 10 times more carbon than any terrestrial forest. So to understand that, we have to have the number, we have to have the one. So conventional methods, people used to go and take 4 5 samples in the forest and they say this is a carbon in that particular sample size, and based on that they do extrapolate to the entire forest. For example, this is for 1,000. For example, if it is 1,000 hectares of forest, they will have take some 10 samples and say this is this much of carbon for the entire forest actually. But as you've seen in the images, there is a lot of dense mangroves, sparse mangroves, and open mangroves are there actually, and different species also there actually. So obviously when you go for carbon market, and that matters. You can't say the numbers, one number to represents the entire forest actually. So they want to know where exactly the carbons are there, how much carbon is stored actually. So if we developed a protocol actually by having a in-depth research with the different research papers and different institutions, and we come up with an algorithm. And as you've seen on screen, this is about the Pichavaram Reserve Forest. And we can clearly see that the dense forest region, whatever we're seeing in the core forest, we have more mangroves, which is ranges around 80 to which ranges to 80 to 100 megagram of carbon per hectare actually. So the carbon ranges from the core forest to the outside forest. You can see the trend clearly shows that the mangrove, I mean the carbon is decreasing from the core forest to the outside forest actually. So this is very useful map for any carbon credit programs and all other things actually. So here the advantages is every pixel we have the value. Sorry for this. Oh yeah. Um, yeah, fine. Next slide is not moving. Okay, so that's about that project. And And the next one is, we are doing one particular project actually is where we do Gram Panchayat based JS plan for coastal districts. So this is extensively we did for Ramnad, even Andamans we did, and some part of Andhra Pradesh also, and Kerala also we did actually. So exclusively we made a Gram Panchayat plan, and this will be useful for all the MGNRG activity. So what are the engineering activity can be taken to have better water quality and improve the green cover, all these things actually. So before you all know that how the engineering works actually, engineering works in a random way. They'll just go and do some lake deepening or some drainage, desiltation work and so on. So government of India will want us to do some of the scientific based work actually, where we use extensively different GIS layers and to understand the different landforms in that particular village level actually, from there we mapped it and we are given different types of works also there actually. The around 270 work 70 plus works are there in MGNREGA approved works, and that works has been given. And for just considering this is a holistic plan of the panchayat, it's not like one particular part actually, the entire panchayat has been planned. And different natural resource management or non-natural resource management also has been mapped, and based on that, that has been submitted to the rural department and they got funding. And from that funding they will do some of the works actually for water security and climate adaptations in the coastal villages as well. So this is also one of the important work we carried out. And yeah, so this is just about how GOAs impacts the coastal livelihood. And yeah, based on this, whatever the work we are doing, actually, it is for the supports of the livelihood. And even our mangrove restoration or blue carbon mapping and monitoring, all these things will be helpful for the livelihoods, coastal livelihood as well, actually. So whatever the work we are doing is not only for just for mapping, it is for decision support systems to support the ecosystem services as well as the livelihood impacts as well. Yeah, again, coming to challenges, we also have more challenges in the GOA, and where we have different challenges such as we don't get proper data also. Some of the institute data we collected from the title data and so on. So that data is also very difficult, and that whatever the data we are expecting from other department also, there is an issues of the ownership also. So these are some of the major challenges we are seeing. And in terms of data and not from the analysis part. And our analysis part and storage and all the things, and we are very advanced actually. So we have very good data storage and we have very good analysis actually, and we got even very near real time satellite images and drone images. We can quickly process and do it actually. Uh, yeah, these are some of the challenges we are seeing. And yeah, so what is the future of GIA in blue economy? Again, the future of blue economy is, we have very advanced satellite images and IoT devices also coming up, and where we can advance our near real-time monitoring of coastal marine systems, where you can have where you can quickly disseminate the advisories to the farmers and fishers in the coastal communities as well. And we can forecast the shoreline also, as I said earlier. We can have very detailed maps and we can do some of the analysis also. And the advantage of all this GOA, the other thing is, we can quickly process and we can quickly give advices. It can reach the beneficiaries very, very fast actually. Because, earlier it will take three weeks or 1 month to process any images and give the data and we'll see. Now, within a day or two, we can do all the analysis and we can do the process actually. This is the future of this one. With this, I stop my presentation. Thank you very much for your patient hearing. Thank you.
Thank you so much, sir. I would like to request our participants if they have any doubt, kindly just ask. So in chat box, one question came, sir. Anuvayani.
Yeah, I'll just read it.
Yes, sir. Yes.
Yeah. Can we be able to estimate blue carbon based on satellite image? Yes. Yes, we can estimate it actually. So as I shown in the Picharam image actually, so that is we use high resolution different type of satellite images, and based on that we assess we quantified the carbon in that particular ecosystem. Yeah, and even our Microsoft project is also we are going to do that actually. So all three ecosystems we are going to work, and seagrass also how much carbon is stored in seagrass meadows and mangroves as well as tidal marsh also we are going to study. Yes.
Okay. Anyone else?
Hello.
Yeah. Yes. Sir.
This is Sudhakar from MSSRF. Sir, I have seen you on your slide in SkySat images. You mentioned 0.5 resolution meter. Yeah.
Yeah.
So on that, is that free open source or you need to purchase any cost?
No, it is not open source actually. So we have to register and we have to purchase that one. In that 3 meter resolution is open source, but that also you have to register as a student and get it actually.
Okay. So frequency, temporal resolutions,
So this image is the CubeSat image is I think 3 days.
uh, 3 days.
Yeah.
Okay, sir. Thank you.
And even we are getting images for daily also. I think for that we have to pay for it.
Thank you.
So any other questions?
Anyone having any questions? Can we map like seaweeds in such a way?
Sorry?
So can we map seaweeds in such a way? The way we are mapping seagrass and mangroves and all?
Yes, actually we can, but it is a bit difficult as well. We are working on it.
Okay, sir.
Even when we're mapping seagrass and seaweed is also coming out. Uh,
Okay,
we are still working on that actually. We can do that. Yeah.
okay, sir. So what is the actual issue coming up while mapping the seaweed? Is the substratum, because it doesn't have a fixed substratum in certain species. So is that the issue, or what is the...
It's basically the reflectance actually. So when you see from the remote sensing images, all will look like a same. Hello.
Yes, sir. Yes,
Sorry,
sir.
it's a network problem. I don't know where I left. So again, I'll just reply to that query actually. So yes, seagrass and seaweeds, we can map it actually. and provided if we have very high resolution drone imageries, and we can do that. Thus, having a satellite image, if both have the same spectral values and spectral reflectance with a slight variation, also it will be difficult. If you have very hyperspectral images or something like that, we can do it. But we are hoping from the hyperspectral, from the drone imagery, we can classify the seagrass and seaweeds.
Okay, sir. Okay, sir. Thank you, sir. Does anyone has any more questions?
Hello, good afternoon, sir.
Yeah, good afternoon, Priya.
I'm Supriya, sir. As you discussed that, how frequently are SST and chlorophyll data sets updated, and how does this affect the reliability of daily PFZ advisories, sir?
Yeah, I'm not really conversant in that process actually. But my understanding is, they're getting the images, daily images actually, from
Okay.
images. Yeah, but I'm not really conversant of how they're doing the process and other things actually. Maybe I can connect sometime with the inquest people for that.
Okay. Okay. Thank you, sir.
Thank you.
I would request my audience to kindly, if they have any questions, ask. You can send the questions in the chat box as well. Yeah, I think many are afraid to ask questions.
Okay. So if there are no questions now, you can write to me anytime.
Yes, sir. Yes, sir.
And talk to me anytime actually, so we can see how we can work on that.
Yes, sir. Shall we conclude, sir?
Yeah. Thank you. Thanks a lot for joining the session. Thanks for arranging this. Thank you.
Thank you so much, sir. So, on behalf of Ms. Swaminathan Research Foundation, Coastal Resources and Fisheries Program, I extend my sincere thanks to all those who contributed to the successful conduct of the 31st session of MSS 100 webinar series. So, we are deeply grateful to our distinguished speaker, Dr. Nagarajan, Head GIS and Remote Sensing, MSSRF Chennai, for giving his valuable time and delivering an insightful and comprehensive lecture on GeoAI for data-driven coastal resource management in the blue economy. I sincerely thank Sir for his insightful and inspiring presentation on GeoAI-driven coastal resource management. His extensive experience in geospatial technologies, AI-enabled Earth observation, and blue carbon research brought exceptional depth and clarity to today's discussion. We also appreciate his ability to connect advanced technology with real-world challenges in coastal and marine ecosystem. Thank you so much, sir, for your knowledge you shared. We sincerely even thank all the participants for their active participation and thoughtful interactions, which greatly enriched today's discussion. We also extend our heartfelt appreciation to the organizing team and technical support staff for dedicating efforts in ensuring the smooth and effective conduct of the webinar. We would also like to acknowledge that and thank HCL Foundation for the supporting this webinar series. Once again, thank you all. Take care. Thank you so much, sir.
Thank you all. Bye bye.
Thank you so much.